Hello guys, today we're going to actually visualize different functions that we have been using till date, like sine, cos, tan. We're going to break them down into their components and see what is the effect of each component on the plot or graph. Okay, let's just start with sine. We have y equal to sine formula for sine is sine omega t plus phi. Instead of omega, we're going to write sine 2 pi f, and that will break it down into further components so we can understand it better. uh, 2 pi sorry 2 into pi into f into the time component. The formula is omega t, right? So omega is 2 pi f, and we need a time component t, which in this case is the x-axis. So we're going to take x plus 5. For 5 we're going to take k2, and we're going to add sliders for them all, right? So the first is the effect of frequency. As we increase the frequency, it's obvious that the rate of oscillations per unit time will increase, so the density will increase, right? That's exactly what is happening. I'm going to bring it to the middle. Okay, now effect of phase is obviously shift. Shift in the sense it is phase is actually angular, right? So the difference in time can be interpreted as angle, right? So for example, in this case, the wave is starting from at 0, it is starting from 0, right? If we shift it a bit to the left, at 0 it is starting from full. So the difference between 0 to full is can be interpreted as 90 degree. All right, so we can say that this wave and this wave has a phase difference of 90 degree, right? That's because we're just dividing this into total is 360 degree, till this is the 180 degree, and this will be 90 degree. I'm going to show you better understand if I use another expression. CZ. In this case, we're going to use K2. We're going to use K1, right? Add a slider for K1. Now, as you can see, frequency is alright. K1. Let's bring both of them to 1. Can I change it? So I'm going to put both of them 1. So now they're overlapping, right? Now, if I just change it a bit, the phase, you can see even though all the other components like frequency and time are same, the phase or the time at which both of them reach peak or start, that is changing, right? Now if we're going to take another function, cos. Cos. So the most evident thing from the cos graph is that it is 90 degree shifted from sine, right? As we know, the phase difference, we always told the phase difference between cos and sine is 90 degree, and one of the famous things that we used to learn is always both of them as k2, and then this is k1. So sine starts from 0 and cos starts from 0. I mean, cos starts from the highest value. Even though both the phases are same, the function have their own phase difference of 90 degree. So this is similar to a sine. Cos is similar to a sine shifted by 90 degree, isn't it? Alright, so to compare, we're going to turn that off and use tan now. So instead of sine, we're going to have tan. Tan. Now tan is difficult to compare visually with sine, as you can see. However, it can be compared with cot. Right, as you can see, they have intersection points and they look pretty much complementary to one another. That's why they can be so easily put into mathematical terms, tan and cot together. Similarly, there are sine and cosec, CSC, cosec. Now this is how they look. They also can be put into mathematics pretty easily, sine and cosec. And we have sec. Now, as you can see, sec doesn't correspond to sine. And what does it correspond to? Obviously cos. When a ton of sine, as you can see, perfectly matches with cos. So cos and sec can be used mathematically in equations. Means they form a simple equation between the relations. Okay, that's it. And one more thing, if you put another variable, we are gonna do it AMP, just A. Alright, so if you increase A, we increase the amplitude, right? So that is the significance of a number. You must have seen variables like A sine omega t plus phi, B sine omega t plus phi. The only difference it makes is the amplitude. It doesn't change the frequency, it doesn't change the phase, it only changes the amplitude. Now if we have another sine function, we can compare B. So we have B, sorry, okay, and they have phase difference. Okay, so B, if we change B, as you can see, the amplitude is changing, right? And it's gonna flip to the opposite side if we take it to the minus. Alright, okay, that's it from now, guys. That's it for now. If you like this video, please hit the like button and you can subscribe. I'll come up with more interesting stuff next. Thank you very much for watching. Have a nice day.